The lifetime of aluminum electrolytic capacitors is almost entirely determined by heat. This heat is comprised of two elements: self-generated heat and ambient temperature. Heat is so critical to product lifetime that reducing ambient temperature by 10 degrees Celsius will double product lifetime. In this video, we focus on ambient temperature measurement methods and introduce them in 3 steps. Heat-emitting elements such as semiconductors and resistors are sometimes positioned around aluminum electrolytic capacitors. In such cases, failing to measure temperature in the right position can cause major errors in measurements. If multiple capacitors are connected in parallel or series, it is ideal to measure the ambient temperature for all capacitors, but this can be difficult. As such, it is more realistic to measure the ambient temperature of the capacitor that is most subject to heat during operation. This is a thermography image of a measured device that has been running for a certain amount of time. We use the capacitor in this position as it is expected to be most impacted by heat. First, remove the aluminum electrolytic capacitor from the selected position to make room for a dummy capacitor. To ensure the circuit functions as designed, use a lead line to electrically connect the removed capacitor and the circuit. Using a thin lead line could cause an imbalance in the current load, so use a large diameter cable to reduce impedance as much as possible. Next, mount the dummy capacitor in the secured space. Make sure the dummy capacitor is not emitting any heat. In other words, make sure the dummy is electrically insulated from the circuit. As an example, here we mount the dummy capacitor by cutting the lead line on one side and affixing an insulating sheet to the cut edge. Ambient temperature elements include heat conduction through substances, heat convection from fluid movement, and heat radiation from electromagnetic waves. When mounting the dummy capacitor, use a method that most accurately accounts for these heat-related elements. Mount the dummy capacitor in the appropriate position for your device. Lastly, measure the temperature of the dummy capacitor when operating the device. Here, the ambient temperature is defined as the average value measured at 4 points around the dummy capacitor. To ensure the same conditions as the actual operating environment, make sure to attach the chassis cover if the device has one. Position the device in the same direction as actual use. Make sure to use the same cooling conditions when using forced cooling. Turn on the device and measure the temperature of the thermocouple connected to the dummy capacitor. For long-term operation, run the device until temperature saturation is reached. This is the ambient temperature of the capacitor. The Nippon Chemicon website allows you to simultaneously conduct lifetime estimations for multiple operating patterns. Now that we have introduced how to measure the ambient temperature of aluminum electrolytic capacitors, next, let's look at how we set ambient temperatures for guaranteed durability. In actual durability testing, we install a standalone capacitor in a constant temperature tank. The tank temperature is set to the maximum temperature for the product category. A fan is used to ensure an even internal temperature inside the tank, but fan air on the capacitor is the same as forced cooling. To prevent this air, the capacitor is placed inside a box. For products with a guaranteed rated ripple current superimposition, the rated ripple current is superimposed so that the peak voltage value does not exceed the rated voltage. The element center temperature is the tank temperature, meaning the temperature represents the ambient temperature combined with self-generated heat caused by the rated ripple current. As you can see, the actual durability test checks the relationship between product lifetime and the temperature that the capacitor receives from the surroundings. In other words, the temperature of the constant temperature tank equals ambient temperature.